Hi everyone, today we're going to be working on finding angles around a point. Yesterday we were working on finding angles around a line, or angles on a line rather. And when we're finding angles on a line, we remember that there's a rule to remember, a math law if you would. And that law says that there's 180 degrees on lines. Okay, when we have to add up all the angles that meet up at a point on a line, there's going to be 180 degrees. When we talk about points, though, we talk about lines coming together and meeting up at a certain point. So if I were to cross my arms like this in front of me, the point where my two arms cross is that point, and going around that point, there's going to be 360 degrees between all of those angles that show up there. So yesterday, the magic number was 180. Today, the magic number is 360 because there's 360 degrees here. However, we don't want to forget our math law from yesterday. That is still going to be a tremendous amount of help for us. And I'm going to show you how that helps us when we get into our first examples here. All right, so let's switch over to the document camera. And here we have me coming down to a more reasonable spot. And line AC and line BD are going to get together and meet at point E. That's our intersection point. Okay, our first job here is to name, let's get rid of this, we don't need that. Name the four angles that show up here. So let's name these four angles. Let's call this, let's find out what that angle is right there. So if I name using the points, there's actually two names that I could technically use, right? So I have angle AEB, the intersection point being in the middle, or if I started at B, could I start at B, go to E, and then end up at A, and I get the exact same angle? You bet. So this could also be angle BEA. Both of those are acceptable answers, okay? Another angle, let's talk about this one right here. That's our intersection point, so we can't start with it. Let's start at B. And I'll go to my intersection point E, and then out to point C. This could also be CEB if I work it backwards, right? Start at C, go to E, go to B. Okay, this third and fourth angle. Give yourself a couple of seconds, pause me if you need to, and think about the names of these last two angles. And this angle right here, going around, we'll call it angle CED, or we can call it DEC if we work it the other way. And over here, we have angle DEA, if I go this way, or angle AED, if I go this way. Now, what if we learn some information about these angle measures? Let's say, for example, that angle AED is equal to 150 degrees. There we go, 150 degrees. Angle AED is 150 degrees. So I'm going to draw this angle arc really big out here. I'm going to write 150 degrees right here, just so that this all shows up on the same screen. What I can do now is find other angles here. And the rule of 360 applies all around. However, I could also use the rule of 180 for points on a line to help me out. So what I'm going to do very quickly is I'm going to take this blank index card right here, and I'm going to cover up half of my diagram. So with that, I now have angle AED and angle BEA. And these together make up points on a line. And I know I have that because underneath the index card, it says that BD is a line. So what I'm going to do is figure that I have 150 degrees and this angle right here. All right, and I'm going to backtrack really quick and remind us, I can't use the rule of 360 right here because I don't know what that is. I don't know what that is. And I don't know what that is. And they're not all the same. So I'm going to use BD as my line and use that information to help me. So I have 150 degrees right here. I realize I can use 180 degrees take away 150 degrees, and I'm going to end up with 30 degrees right here. So angle BEA is 30 degrees, and angle AED was 150 degrees, right? Well, now I have two angles that are missing still. And you know what? I know that AC is a line, so I'm going to cover it up this way. So now I'm going to find angle BEC. I'm going to find this missing angle right here. Well, I know if this is 30 degrees, this has to be the remaining part of 180 degrees. And I know that 150 plus 30 gives me 180. So angle BEC is 150 degrees as well. And finally, I have this missing angle right here. Well, I could use line BD to help me find that. I can use line AC to help me find it, or I could use the rule of 360. So what I'm going to do right now is I'm going to do some mental math and say 150 plus 30 is going to give me that angle. But I'm going to use the rule of 360 to check to make sure that that's a correct answer. So I'm going to take the three angles that I have already, 150, 150, and I'm going to get 300, add 30, and I'll have 330. There we go, now I'm on screen. And then I'm going to take the 360 total degrees, subtract all three angles that I have so far, and this is going to give me 30 degrees for my fourth angle. So using the rule of 180 or the rule of 360 for angles around a point, I have proven that this angle, CED, is 30 degrees. Isn't math wonderful? There were two ways of doing this problem. And in fact, in section 12.3, which we may or may not get to, we're going to take a look at a few things. These are actually called vertical angles. Notice how these angles across from each other are congruent. And congruent is a word that means equal in geometry. These two angles are congruent as well. And that's because these are two lines that pass through that intersecting point, and they form these vertical angles. So vertical angles, we can think about opposite angles. They're going to be congruent because we have these two lines here. But that's a lesson for another day. Let's talk about some more angles around a point now. And here, in this system, I wasn't nice. I didn't give us lines to work with. What I did give us were a couple of line segments. They're not named because all this problem is asking me to do is find the measure of angle y. So here I have a 110 degree angle, and here I have a 125 degree angle. What I need to do is add 110 plus 125 degrees, and that's going to tell me how many degrees I have in these two angles. Why is that important? Because I need to know how much I have altogether in those two angles so that I can figure out what's left on this angle. So I'm going to go ahead and add 110 plus 125 is going to give me 235 degrees. What's left over is going to be what y is equal to. Well, I know that going around this point is like going around a circle, and there's 360 degrees minus 235 degrees, and I'm going to be left with 125 degrees in angle y. I almost said point y, and I realized that wasn't correct. So the measure of angle y is 125 degrees. Okay, and now we have one more problem on this slide, and this is angle XYZ. And the problem over here tells me that angle XYZ is 105 degrees. Angle XYZ is this interior part right here, okay? So I'm going to use this marker right here just to shade this and tell us that this is 105 degrees right here. The problem, though, is asking me for angle P. And angle P is this reflex angle on the outside? Okay, it's outside the angle. Well, it's going around the point. Part of the distance around the point is 105 degrees. What's the rest of this distance going to be? Well, I can use the same rule of 360, can't I? If I do 360 degrees and I take away the 105 degrees here, if I do 10 minus 5, I'm left with 5. I borrowed, so I have 5 minus 0 is 5. 3 minus 1 is 2. So this exterior angle right here is 255 degrees. Okay, and we used a little degree symbol. On Google Forms, we've been using the word degree because it's not easy to get that degree symbol in there. All right, a couple other examples for us so that we can challenge our brains a little bit. This is one of the note sheets that I would use in class. So that's why it's hand drawn out. I'm going to write on these Post-its here so that my writing is a little bit more clear for you guys on the computer. So I have two angle A's, and algebraically, we would call this 2A, right? It's A and A, so that's two A's. So that would be something that means that they're equal to one another. Over here, I have 160 plus 110, okay? So I have 160 plus 110. So between these two angles that I know, I have 270 degrees. If I subtract 360 minus 270, right, rule of 360 around a point, minus 270, the degrees that I already have, I'm going to be left with 90 degrees. So together, these two angles, these two A's equal 90 degrees. Well, if I know that two A's equal 90 degrees, then I have to do some work to figure out what one of the A's equals, okay? Remember that we said that there's 90 degrees left between these two angles, okay? So that's why I'm saying that both of them are equal to 90 degrees. So in order to find what one of them is, I have to separate this out and figure out, well, if I have both of them are the same, I have to have an equal portion. Can't I divide? So I'm going to divide by 2 and divide by 2. And A is going to be 45 degrees. Doesn't look like it. Doesn't look like this was 90 degrees altogether. Math in Focus would say not drawn to scale. I'm not Math in Focus. So therefore, A here is 45 degrees. A here is 45 degrees. And that's my answer. Down here, we had to find the measure of angle N. So I have angle N is right here. I have 148 degrees here and 165 degrees here. So let's see what angle N is. Thinking about my procedure, I start out by adding up what I already have. I know I have 148 plus 165, and that's 313 degrees. And then subtracting from 360 degrees, do some borrowing for us. So I have 10 minus 3 is 7, 5 minus 1 is 4. So angle N, the measure of angle N equals 47 degrees. And one final problem for us. Nice little challenge here. Lots of information here. So let's read through everything. RT is a line. So my line connects R and T here and goes through point Q. All right, we need to find RQS. In a crazy problem like this, I always like to make sure I know exactly what angle I need to find. So if I have this on paper, I sometimes trace it over. I might, if I have my mouse, I might put it in that angle. So I'm going to do that for you, since this is probably how you're going to be able to do your work. Find the measure of angle RQS. So RQS is right here. We're finding that angle. On my board, I'm going to draw a little angle arc in there, so I know exactly what I need to find. Now, Angle PQR is a right angle, okay? And angle SQT is 130 degrees, okay? 130 degrees. Now, there's two ways of solving this problem. I could solve this problem by using angles on a line, can't I? Taking my handy-dandy index card, I know that that's a line right there. And I could easily solve by subtracting from 180. However, let's do this with angles on a point. And let's use 360. So let's see if we can figure out this angle by checking out what all the other angles are going to be. If I have a right angle right here, that's 90 degrees. The other side of that on the same line is also going to be a right angle. It's also going to be 90 degrees. So far, I have a 90-degree angle right here in PQR. I have a 90-degree angle right here in PQT. Altogether, that equals 180 degrees, and that's this side of line RT. I'm going to add 130 degrees, 18, 21, carry. I have 310 degrees so far. Now, if I move this up really quick and I do 360 degrees minus 310 degrees, I'm going to have 50 degrees left over. So angle RQS is 50 degrees. And I'm going to use angles on a line to help me out since I have RT here conveniently. And I can realize, hey, I have 130 degrees plus 50 degrees. Add them together, I have 180 degrees. So it's another way, because we have that line there, to check my work to make sure I did it correctly. Today, you're going to be working on a Google form again. And that Google form is loaded in with a few questions. There's a vocabulary question here. Read each of these questions carefully to figure out which angles we're talking about and what you're solving for. Make sure you're looking at what we're looking for here with angle AOB. Okay, notice the other ones are drawn in for you. And scrolling down, you'll see some repeat questions showing up here because we have angle TQR in one question. All right, the question before it asks you about angle PQS. So make sure you're reading the questions very carefully. You can look for angles on a line. You can look for angles around a point. Check your work very carefully. Make sure you're subtracting appropriately. If you have any questions, as always, please make sure you reach out to us. Have a great time working with angles on a point.